Alright, so in this video I will talk about how to organize how to organize categorical data. Categorical data. So let's first recall what do we mean by a categorical variable. Categorical variable. A categorical variable is simply a variable that takes on non-numerical values or qualitative values. So it's a variable that takes on non-numerical values, or you could say qualitative values. So that is the characteristic of the population that we are interested in, is a qualitative trait. Okay, so when the variable is a categorical variable, then the data values can be classified into categories. And for example, blood type. So examples of would be blood type, hair color, it could be let's say employment status, and you can think of many other examples. Now the question is, how do we organize categorical data? Well, let me explain this with an example. Let's say we want to determine the percentage of people who are unemployed in Ada. So let's say this is the question we are asking. What percent of what percent of people, or let's say what percent of adults in Ada are unemployed. Let's say this is an assignment in one of your class to answer this question, and let's say Ada has a population of 7,000. So there's got to be a couple of thousand adults living in Ada, And so how would you answer that? Would you survey every single adult in Ada? Maybe that's too expensive for you, so you would rather take a sample of, let's say, mm, let's say you would take a sample of 600 people. Okay, let's say 500 people. So you take a sample. You take a so you take a sample of 500 adults to survey about their employment status. So the variable we are studying here is the employment status of adults in Ada, and the population units are the adults in this case. And so your survey basically asks, are you employed or not employed? So so there are two possible qualitative values to this for this variable. Either people are, so we can divide our 500 adults into two categories. One would be those who are employed and those who are unemployed. All right, so let's not talk about how you should design the survey. Of course, the way you survey, you have to be careful how you select your sample, of course, because you want to make sure that there is no bias when you pick your sample. But that's another story. Let's say you have surveyed in a careful manner, that we don't have to worry about it. So you have selected 500 adults. You give them the survey, and they give you their responses, and each of the 500 responses is either unemployed or employed. So using those 500 responses, you can determine the number of responses which were employed and the number of responses which were unemployed. So let's say the number of responses that were employed was, let's say, 400, and the number of responses that were unemployed, let's say, is 100. Okay. Well, so we will call this, so each one of this is a category, and this is another category. So we have two categories here, and these numbers here are called counts for each category. So this is the count for, so this is known as count, the count for each category, or we also call that frequency for each category. For the frequency or count for the first category is 400. The count or frequency for the second category is 100. All right, so now how do we represent this information with using a graph? Well, the first graph that I'm going to use is called a bar graph. It's called a bar graph. So how do we represent this data using a bar graph? Well, basically for each category will be represented by a bar or a rectangle. And so here's my x-axis. Here's my horizontal axis, and let's say here's my and let's say here's my vertical axis. So for each category, let's say I'm going to for each category I'm going to have a bar or a rectangle. So both bars or rectangles will have the same width. So let's say for let's say this height here is 100, 200, 300, and 400 is right here, and this would be 100. And so for unemployed category, I make a rectangle where the height is given by the frequency of the category, and then here's what I call unemployed. And then I make another rectangle, and in this case the height of the rectangle would be 400. So this is for employed. Okay, so that's how I can make a bar graph for the above data. Now instead of using frequency, we could use relative frequency. So let me do this. So let me make another table now. So here is my category employed, and here's my category unemployed, and the frequency, the frequency for the employed category was 400, and for the other category was 100. And the total frequency is of course the sample size, so the total here, the total being 500. And then I have relative frequency, and so relative frequency means the ratio of the frequency of each category to the total. So 400 divided by 500, which is 0.8. 400 divided by 500, that's 0.80, and 100 divided by 500, that's of course 0.20. So this is 80% and this is 20%. So the percent relative frequencies are 80% and 20%. And of course, if you look at the total of the total relative frequency must be 1. The relative frequencies must add up to 1 or 100%. If you're writing relative frequency in percent, then they must add up to 100%. So instead of taking the height of each bar to be the frequency, we can take the height to be the relative frequency. So once again, here's my vertical axis, horizontal axis. So let's say here is 20% height, or 0.20, so 0.4, 0.6, 0.8. And so for the people who are unemployed, for that category, so unemployed, and I have another bar for the employed category. So again, here we took the height to be the relative frequencies instead of the frequency. Now we have a choice here. Either I can draw the bar for the employed category first, or the unemployed category first. But if we draw them so that if we draw the bars in decreasing order, that's called a Pareto chart. Pareto diagram or a chart is that you draw the rectangles in decreasing order of height. So here is the unemployed category. Here is the employed category. So here is my 80%. Here is my 20%. Okay, so a Pareto chart is then basically a bar graph, but the heights are taken in decreasing order. Okay, so that's how we can represent the data using a bar graph. Now, instead of using a bar graph to represent our data, we could also use what we call a pie chart. A pie chart. What it is that is the following. Instead of using bars, we could use a disk to a disk like this, let's say, and then we could allocate area of slices of this pie according as the relative frequency of each category. So remember, for the employed category, let's say unemployed category, the relative frequency was 20% or 0.20. That was the relative frequency. And so how big of a slice do we allocate for this category? Well, it will be 20% of the whole pie. And one way to figure that out is that you multiply that by 360 degrees, and which is equal to 72 degrees. Okay, and so you allocate a slice, let's say like this, where this is 72 degrees, and that's the slice for unemployed, and the rest of the pie will represent the employed category. Okay, so that's what a pie chart is. Now, this calculation that I did here is that the whole pie means I have 360 degrees. So the 20% of the pie, a slice which is 20% of the pie, will create a central angle which is 72 degrees. Okay, so that's how we can create a pie chart to represent the same employment status data. Alright, so next I have another example. So here's let's say you are trying to decide the top 10 causes of, you're looking into the top 10 causes of death in the United States in the year 2006, and so the top 10 causes are listed here, and so whatever sample you pick out of that, you found out the frequency for each category, each of the 10 categories, and then you computed the percent relative frequency for each of the categories, and then of course we can make a bar graph for this data, which will look like this. Notice that when I have the bar graph in decreasing order of height, that's what is also called a Pareto chart. If we rather organize our bars in the second way here, then you can notice that that the Pareto chart is better because it shows us right away. It helps us to compare the different causes. Obviously, we see that the number one cause is heart disease among the 10 causes. And we can also draw a pie chart for the same data. So for each category, we allocate a slice according as the relative frequency of that slice. So 34% of the pie will be allocated for heart disease because that's the relative frequency of heart disease. 30% of the pie will be allocated for the cancer because that's the 30% is the relative frequency of the category cancer, and so on. When you are making the pie chart, you have to make sure that your percents, they add up to 100%, and so on, and make sure that you're labeling your categories, and you're labeling the slices correctly. All right, so that's how you organize and present categorical data. Next time we will talk about organizing quantitative data.